Ladies and gentlemen, my name is Astha.
Hi, this is Shruti, and we would be your host for the day.
It gives us immense pleasure to welcome you all to the second edition of CCD Bhopal, the Cloud Community Day Bhopal 2023, brought to you by GDG Cloud Bhopal.
Cloud Community Days is all about celebrating the power of cloud computing and the endless possibilities it presents for businesses and society as a whole.
And we hope that you are just as eager as we are to get things starting.
So, to set the tone of the event, I cordially invite the pillars of GDG Cloud Bhopal, Mr. Aditya Shah, and hosting support lead at INSUB LLC, and Mr. Mayur Rathi, consultant at Capgemini.
So let's jump right in and enjoy the afternoon together.
Hi everyone. Hello. Good morning. How is the Josh? Excited? So I welcome you all in today's Cloud Community Days event. This is the second edition. We are hosting CCD in Bhopal for the second time. Last year we started this community. Okay. Now we have grown 100x. Can you clap all for all of us?
So my name is Aditya Shah and I'm working as a hosting support manager at INSUB LLC.
My name is Mayur. I am cloud consultant with Capgemini. I am multiple Google certification as well. I am a technical trainer as well.
Thank you, Mayur. So I and Mayur, back in 2021, January, came up with an idea since we were working with cloud. So we came up with an idea to start a community of cloud developers or cloud users in Bhopal. So we started this community thinking of joining everyone who is involved with cloud, no matter it is Google Cloud or AWS or Azure or DigitalOcean, whatever. We wanted everyone to come together and talk about cloud, bring networking and provide job opportunities. There would be job seekers, there would be different kind of opportunities for everyone who is involved with the community. So that is one of the reasons that we are doing this kind of events, so we can all come together and learn from each other, network with each other, do certain things together, collaborate, right? So this was the motive behind our idea of making this community. And let's make this community a vibrant one. So we grown from 21 to 2100 people. And we like that's just in one year or similar, right? So let's hope that we keep these numbers increasing every year by 100. So let's become 21,000 next year, and similarly grow and grow and grow more, right? So let's clap for all of us. Thank you.
So let me give you a brief who we are. So just as you, way back in 2016, I guess, I met Aditya. Okay, we were student developers and organizers of student communities at that time, and we started doing community work around 10 years back. So we started with multiple communities. He is already managing other open source communities such as WordPress. You know WordPress? Yes or no? And he is pro at that. तुमको कुछ भी जानना है इसको connect करना है. ठीक है? Similarly, like if you need any more references, we have a range of speakers with us today. These are industry experts, Google experts, and best in their own domain. Okay. So उनके detailed sessions होंगे and during the breaks, okay, please try to reach out to them and to try to get some more career guidance. Additionally, why we wanted to start this community, to give it back to the students. Okay, we were students once. हम भी भोपाल से ही हैं. We are based out of Bhopal. Okay, and we have seen that what is the career gap. Okay, what is the education gap in the industry, and the education we have at our universities right here. So also additionally, we have reached out to additional principal secretary. Okay, he would be here to facilitate this event, and we would try to ask him to enhance our curriculum as well. So that is our goal, and we are hosting this for all of you. Earlier we thought we would do it for a shorter audience, but I wanted you all to get an experience, a conference experience. That is the reason we are hosting this community. Now talking about Google Cloud Community Days, what it is. So this is a flagship event of GDG Cloud Communities. Okay, there are 20 such cloud chapters across India, and if I talk about GDG ecosystem, we have 70 plus chapters, and globally it has hundreds of chapters. Okay, so being a member of GDG Cloud Bhopal chapter, you can consider yourself as a member of global GDG community. Can you clap? And not just in Bhopal, you can search for these similar communities in Bhopal, in nearby region, at your hometowns, at tier 1, tier 2 cities. But we are trying our best to give and to host events right here in Bhopal. So if you want very specific events on certain technologies, please feel free to reach out to us on our email IDs. Okay, we will try to get experts, not for these flagship events, but on a regular basis also. Okay. Now, additionally, let me give you a brief of today's lineup. So today we have 10 speakers with us. Okay. So we would start at 10. We have already started. Okay. With technical sessions, we would start. In between, there are 2 activity breaks. Additionally, we would be having lunch break at 1. Okay. Apart from this, at the end of the event, we would be having a panel discussion, like what you can do. That would be basically a panel discussion on career guidance. So that would be very key for you. Please look for it. And at the end of the event, feel free to collect your swags, then only leave from the venue. Okay? And I would like Aditya to add more if I have missed any points.
I think we have covered almost everything. So I think that I would just say one thing, like, class for us.
Okay, thank you. Yeah.
Thank you, Mr. Aditya Shah and Mayur Rathi, for your opening remarks. All right, folks, as you know the drill, before calling up on the first resource person for a later surprise, it's time to spread the word and get this started. It would be great if highlights of the event reach all of your tech-savvy friends out there. So let's make some noise on social media. Show us your best hashtag name, and let's see those posts flying high with the hashtags we have got on the screen. So grab your phones, fire up your accounts, and let's get hashtagging.
The hashtags would be on the screen in a while. Till then, starting with the amazing lineup of speakers, I cordially invite our foremost speaker, Mr. Abhishek Sharma, the cloud engineer at SIAC, a Google Cloud Champions Innovator in hybrid or multi-cloud, a Google Cloud Certified Professional Cloud Architect, a Google Cloud Mentor, a blogger, and a cloud teacher on YouTube. During a session, he will be sharing his expertise on architecturing with Google Cloud, which will cover the concepts of cloud architecture, tuning your architecture,
Hello, hello, hello. Am I audible? All of you? Am I audible, right? Last? No? Yeah, I think I'm audible. Okay. So, hi everyone. This is Abhishek Sharma. I have a separate slide for my introduction. So, let's get started. So, today we are going to talk about architecting with Google Cloud. So, how many of you are aware with architecture or architect? Have you heard about this particular word, cloud architect? How many of you? Just raise your hands. So, yeah, there are lots of folks. We have one more mic so that we can provide to. Yeah. So, who is going to tell about who is cloud architect? Then I will brief you about exactly what is cloud architect and what they do and how you can utilize that particular learnings for your use case or for your applications. So, yeah. So, this is my brief introduction. Who am I? So, currently, I am a cloud engineer at Sears and Google Cloud Champions Innovator in hybrid or multi-cloud space. So, I more work on Anthos, one of Google Cloud product. I also am a Google Cloud mentor, a blogger, and your neighborhood teacher in one of the YouTube channel that is Guys in the Cloud. So, this is my brief introduction. So, yeah. So, this is the agenda. We are talking about, first we'll talk about what is architecting in cloud, and then we'll see what are the fundamental points of architecting in cloud, and then how to choose Google Cloud services based on that, and then we'll see one of the amazing tool from Google Cloud, that is diagramming tool, and then I will give you some additional resources so that you can utilize those resources in your architecture, and then we'll see how Google help you tuning your architecture based on some kind of recommendations or suggestions actually. So yeah, before moving forward, let's talk about what is architecting in cloud. So some of you guys already talked about, already know what is cloud architect and what they do, right? So anybody who want to answer this particular question, who is cloud architect? Yeah. Can somebody help with mic, please? Yeah. Is it a buzzing word for you guys? Architecture, architecting in cloud? Yeah. Okay, that is good thing. Anyone else? Yeah. For people who are sitting above, they don't have this
बेसिकली
practice.
क्लाउड आर्किटेक्चर जिसको क्लाउड के बारे में सब पता हो कि लाइक अगर मुझे कोई सर्विस बनानी है तो बेसिकली तीन तरह की होती है प्लेटफॉर्म एज अ सर्विस इंफ्रास्ट्रक्चर एज अ सर्विस एंड सॉफ्टवेयर एज अ सर्विस तो किस नीड के लिए हमें कौन सी सर्विस यूज करनी है वो आर्किटेक्चर डिजाइन करता है कौन सा उसमें डाटाबेस यूज करना है ये पूरा आर्किटेक्चर और कौन सा लोड बैलेंसर लगाना है कब उसको स्केलिंग करना है कितना करना है basically this is a cloud architecture.
So this is one of the great example actually. So basically as a cloud architect, as a cloud architecture, right, you have to make sure that whenever your application, yeah. So yeah, nice one. Okay. So whenever your application goes to cloud or any of the cloud platform, how we are gonna build that particular application so that it can able to serve millions of users without any hacking issues or something like that, right? So we'll talk about all those things. First we'll check what is architecting in cloud. So I think this is visible to you all, right? Have you heard about this particular word? Flipkart, Chrome, Google Maps, YouTube, Gmail, Disney Plus Hotstar, right? We every time, whenever like India versus Pakistan was over there, right? We always talk about this particular thing that, yeah, this time Hotstar meet this much of users, right? Live at that particular point of time. So have you ever worried about this particular thing, that how their engineers work behind the scene? They can able to serve application like this, which is serving this much people, right? This is amazing thing, right? Daily basis or in every match, there are lots of folks over there who are watching that particular match, and their backend can able to handle that much traffic. So how they have built this particular architecture? So basically, behind the scene, if you have your application, you have to take your application into the cloud in a way that it can able to serve millions of users without any latency issue, without any error or something like that. Also, there are some more concerns, like if you are putting something in cloud, we just have to pay for that particular amount which we consume. This is the basic funda, right, in cloud. But you have to make sure that you are not billing for lots of amount of money, right? Because if I just go to cloud and provision thousands of VM, I have to pay for that, and your companies have to pay for that, right? And if you are the owner of the company, after some time you are like, kahan pe dal diya yaar, itna sara billing aa raha hai, right? So these kind of situations are over there. Also, there are, like, if something happens to your application or some hackers try to hack your application, then all your users data get compromised, and this is not a best practice. You put your application in a way, right? So architecting or configuring your application in a cloud that it can able to serve your application with reliability, with security compliances, and with cost optimization is called as architecting in cloud. So behind the scene, every cloud platform having structure like this. We just have some kind of end user, and then we have some kind of load balancer in place. We have some cloud armor. If we talk about Google Cloud for the security purpose, then we have multiple backends so that we can give a high availability thing, and we have monitoring and logging solutions over there. This is from a user prospect, and this is from a you can say, engineer prospect who is working on that particular application for the reliability. But behind the scene, there are a lot of developers like us, right? Whenever we build an application, every time, let's talk about Flipkart. So कुछ टाइम के बाद वो आता है क्या, सेल्स के लिए एक आता है, राइट? कुछ टाइम के बाद सेल आते हैं वेबसाइट्स पे, राइट? सो डेवलपर हैव टू पुट दैट सेल बार in your application. So this is a new rollout, right? From this particular date to this particular date, we have a sale, right? And there are lots of products which comes under that particular sale. So if I have some kind of automation tool over there where we just have to change that particular part and it automatically rolled out into your existing application, then this is the best practice, right? From a developer prospect. So these kind of things we normally have while architecting in cloud. Yeah. So let's talk about what are the fundamental props while architecting in cloud. So what do you think? If I want to put my application into the cloud, what are the things I have to consider while architecting in cloud? Let's suppose one of the example is cost optimization. I need to make sure that I'm not spending lots of money over there, right? Based on use case, based on user. Let's suppose इंडिया वर्सेस पाकिस्तान है, वहाँ पर 1.2 बिलियन यूजर्स आ रहे हैं, राइट? सो उस टाइम पे तुम्हारा जो बैकएंड है वो बहुत ज़्यादा लगेगा. लाइक लेट्स सपोज इन द प्रीवियस स्लाइड आई जस्ट यूज्ड this particular 3 VMs, 3 backends behind the scene. But let's suppose इंडिया वर्सेस पाकिस्तान है, वहाँ पे 1.2 बिलियंस कितने सारे यूजर्स हैं. सो 3 से काम चलेगा क्या? चलेगा क्या? नहीं. अगर हम कोई मशीन लर्निंग का एप्लीकेशन अपने खुद के लैपटॉप में चलाते हैं और अगर बहुत ज़्यादा बड़ा डेटा सेट ले लिया, मॉडल चला रहा है, हमारा लैपटॉप क्या हो जाता है? क्या हो जाता है? हैंग हो जाता है, राइट? सो इन द सेम वे क्लाउड में भी अगर तुम्हारा वर्कलोड बढ़ेगा और तुम्हारे पास अगर लिमिटेड रिसोर्सेस हैं तो तुम्हारा पूरा बैकएंड डाउन हो जाएगा. बट कभी ऐसा देखा है कि हॉटस्टार डाउन हो गया इंडिया वर्सेस? नहीं, राइट? ऐसा कभी नहीं होता, राइट? So they have configured their architecture in a way that they can scale up to a threshold so that they can able to serve n number of users, right? So this is how they architect their application. So scalability is one of the parameter while considering architecting in cloud. Second one is cost optimization. If I am having hundreds of VM all the time, so I have to pay for that 100 VMs, right? But if there are less number of users, I can scale down up to 3 VMs. It can able to serve, and as soon as more users comes into our application, I have to move to 100 number of VMs, right? This is how we configure. So this is the second parameter. Apart from that, anyone else you have in your mind what are the fundamental points while architecting in cloud? Security is one of the parameter. Anything else? No? Be interactive, guys, please. There are lots of things already mentioned in the slide. Operational excellence. This, I think CI/CD part is over there. Then performance optimization, then reliability is also over there, right? So these are the fundamental points you have to consider while you architect your application into the cloud. Okay. Okay. So now we know what is architecting in cloud. Any doubts? No? Everything is clear? यार इतना अच्छा नहीं समझा रहा मैं. Okay. So just be interactive, right? Okay. So let's suppose, assume करते हैं तुम्हारे पास एक simple सा application है. Let's suppose your portfolio. Now you want this particular portfolio is hosted into the Google Cloud. So how you are gonna proceed for this particular approach and how you are gonna architect your portfolio into the cloud. So first thing is how to choose a Google Cloud service. So as mentioned by, I don't know the name, but yeah. So architect is the person who know everything about any specific cloud and they know their best practices so that they can choose best solution for a specific application, right? So in this particular slide, we are gonna see how to choose a Google Cloud service. So have you ever interacted with this particular diagram? No? So this is from Priyanka ma'am actually. Developer cheat sheet. So in this particular cheat sheet, you have all the services which are present in cloud, especially in Google Cloud actually, and how to choose those services based on your requirement. So let's suppose you have your portfolio. So as you build your portfolio in your local laptop, you have memory and CPU power in your laptop and you are using that particular memory or CPU power to host your application, to run your application. If I want to same thing in cloud, which particular field I want? First one is compute, right? Because it has some kind of processing power, right? So for that, if you see this red block, this is related to compute power, right? Whatever machine learning application we build, whatever portfolio we want to build, first I have to choose my compute offering. Then maybe chances that we are using some database offering over there. I have to store my user information in some databases or some like let's suppose Flipkart is over there, right? So whenever user comes to Flipkart, I have to store their data as a user, valid user. Then next time it comes to our website, I have to use those credentials to log in into our application. So for that, I have to use storage solution, databases. Then if I want to see how many purchases I have in this particular month, then I have to do some kind of analytics, right? So for each and every use case, whatever you want to do, we have different services. Like in compute, we have compute engine instance, like the same you have laptop, right? If I want to run a containerized application, I have Cloud Run or Kubernetes engine in compute offering. For storage, based on type of data, if we have relational data, have you ever heard about this word relational database? Yeah? Anyone want to say something? What is relational database? Yeah? Just raise your hand, someone put your mic. No? Why? Okay. So basically, based on our type of data, right, we have three kinds of data: relational, non-relational, and semi-structured data, right? So based on that, we have different offerings in Google Cloud Platform to store your data. Also, if I want to do the analytics thing, I have list of services which I can utilize and use in that particular thing. Also, while architecting in cloud, security is one of the main concerns. For that, we have identity and security. So let's suppose I am a cloud engineer in some specific company, or I am building a specific application into the cloud. So I have to make sure that based on my recognition, I can only access those services where I have access, right? Let's suppose I am a network engineer, so I just have to access to network resources, right? This is the best practice. So based on those use cases, based on your thoughts, right, you can able to choose these number of services uh, present in this particular slide. Okay, now we know if I have a portfolio site, I can build this particular portfolio site in the cloud compute engine instance. Then I can use the storage thing, then I can use some identity and access management so that I can enforce the security. So now, how to build your architecture in a diagrammatic way? Because if I just go and show you that in a list of contents that this is how I am going to enable the security, how I can use the compute resources and all those things, this is not a good practice. I have a pictorial view so that I can show, yeah, these are the things, this is how it is working, ऐसा data जा रहा है, इधर से यहाँ process हो रहा है, then this is how it is working, right? So that is the good way of presentation actually, where I show you in a way that it is a pictorial and how the data is flowing. So for that, Google is having their amazing tool that is called Google Cloud Architecture Diagramming Tool. Yeah. So what are the flexibilities this particular slide, this particular tool will give you? First, you can able to your architecture diagrams, and then you can also take a reference from a previous pre-created reference architecture. Let's suppose you are building a data pipeline, right? You have lots of data you just want to ingest into your application and do some kind of processing. So in Google Cloud Platform, we already have some architecture created with the best practices by the Google Cloud Architect. You can just go and take the reference. I will show you how to take the reference. And after that, you can deploy your architecture in one click. So it is not like you are building your architecture in a pictorial view. If you are using this particular, you just go and click whatever resources you have built in that particular architecture, it gonna deploy automatically. You don't have to separately go and create different resources. So I will show you how amazing it is. Yeah. Hello. Yeah. So this is the first part, build architecture diagrams. So here if you can see, there are lots of tools, whatever tools we discussed, right? In the last slide, there developer cheat sheet. So just take those services and pull it here, drag and drop, drag and drop, drag and drop. That is the only thing. So this is how you can build. I just taken Cloud Run and then Cloud Storage and then Firestore. So this is how you can just drag and drop and create your architecture. So this is building a serverless application in Google Cloud where I have a user which is accessing Cloud Run, which is serverless offering in cloud, and it is going to take some data from Cloud Storage and Firestore, and after that I have BigQuery for the analyze purpose, right? So this is how it looks like. I just need to drag and drop the resources and map it. This is how I can build architecture diagram. It is very easy, right? It's not a rocket science. You just go and drag and drop the services and your application is up and running. Yeah. Now, how to access the pre-built reference architecture? So maybe chances that if you are a beginner, I don't know much more about how to architect in cloud. So let's suppose you have a use case that I just want to host my portfolio application in cloud. So we already have lots of reference here which you can utilize, like sample app is over there, cloud architecture, containerized application. So you just take that particular part and pull it here. Automatically this whole diagram will come into the picture, and this is created by Google Cloud Architects with the best practices, and all the security compliance, scalability, all are handled by Google itself, right? So this is how you can just drag and drop, pull your application and build your architecture automatically. Yeah. And after that, there is a one more hack is over there, deploy with one click. So let's suppose I build my application. Okay, now if you just go to Google Cloud Platform, have you ever interacted with Google Cloud Console? किए हैं ना साबरे? GCRF program, there are lots of programs over there, right? So वहाँ पर हम जो cloud से console से interact करते हैं, so for each and every lab I have to go inside my compute engine resources, storage resources, ताकि मैं उसको create कर सकूँ, right? This is how we do. But here, if you just create your architecture diagram, below we have one button, run in cloud cell. Automatically, whatever resources you have put it in that particular architecture get deployed automatically. Let's suppose we have an architecture of load balancer. I think so. Here, if I clicked, just hold on, it will come again. Okay. So let's suppose I just wanted to host my application with MIG, where I have some load balancer and having some kind of machines over there, which is running my application. So I just have to create an architecture diagram. These are my MIGs, matlab virtual machine instance. On top of that, I have a load balancer, and I just want an endpoint. So this is the architecture diagram. Load balancer is over there, compute engine is over there, and we have some devices, right? So I just created a sample diagram like this. And below we have one button, open in cloud cell. So you just need to click on that particular button. So can you just go back and come back here again? No, it's not running actually. Go back. Why it is not running? No. Okay, so after this particular thing, you just have to click on this open in Google Cloud cell. Automatically, whatever you have mentioned in this particular architecture, one load balancer, some MIGs, so automatically this particular thing is deployed in your Google Cloud platform. This is how it easy. Like you just need to create a diagram, just few clicks, and your application is up and running over there, right? So this is how you can deploy your application in one click. Yeah. So let's suppose we have some kind of additional resources where we can utilize Google Cloud knowledge over there. So here we have one website called Google Cloud Architecture Center, where we have lots of architectures already built. So you can utilize learnings from here related to system design, reliability. Just go learn about it, create your architecture diagram, and you are good to go in one click using the same thing. Yeah, so these are the resources. Now, the last part is that tuning your architecture with Google Cloud. So let's suppose you build your architecture with roughly basis. I'm using tens of MIGs, tens of VMs, lots of load balancer. So let's suppose you are expending very high amount of money, right? Because I have created lots of resources. Okay, so Google will help you how to how to optimize your resources into the cloud. So we have one recommendation section over there where you can utilize, like you are spending this much amount, you can spend very less. So this is how Google will help you by recommending different parameters, and you can save your cost. So this is all from my end, guide. Thank you and have an awesome journey.
Thank you, Mr. Abhishek, for sharing insights and shedding light on such a significant theme. So, our esteemed chief guest has arrived. We are absolutely delighted to have amongst us Mr. Manu Srivastav at the Cloud Community Day Bhopal 2023. It gives me immense pleasure to introduce our esteemed chief guest for today's event. Mr. Manu Srivastav, who has kindly agreed to grace this occasion with his presence, is currently the Principal Secretary of two departments, namely the Department of Technical Education, Skill Development and Employment, and the Department of Cottage and Rural Industries in the Government of Madhya Pradesh. Mr. Manu Srivastav. Thank you. I'd request Sir to kindly come up on the stage, and Mr. Aditya Shah and Mr. Mayur Rathi, organizers of GDG Cloud Bhopal, to kindly welcome our honorable chief guest. Mr. Manu Srivastav is a 1991 batch IAS officer, and he holds a BTech and MTech degree from IIT Delhi. I'd request the organizers to kindly welcome Sir with a bouquet. Thank you. Thank you, sir. I would like to request Mr. Srivastava to kindly address the gathering, and we are eager to hear his valuable insights and thoughts on the role of technical education in driving innovation and entrepreneurship. Please join me in welcoming Mr. Manu Srivastava, IAS, with a big round of applause.
It's a great pleasure to be here and to be interacting with all of you. Uh, really, technology has come along in a long way. As was mentioned, I myself have a technical background. I studied in Delhi IIT. I did electrical in Delhi IIT. I did BTech and MTech there. And most of my work in the government has also been something to do with technology. So it gives, right now also I'm working in a department that looks after technical education, skill and employment. So that means all the engineering colleges, polytechnics, ITIs, etc., skilling, such things. I look after that. So I have a natural interest or inclination towards these things. It's a great pleasure to be here. I must share with you how fast technology is changing. When I joined IIT, at that time, the computer center that we had was something twice this room, but that was the computer itself. So the computer was that big, and perhaps it had as much power as a mobile that I carry or any one of you carry. So at that time, how we used to function on the computer was that there used to be dumb terminals, and you would input on your program on that, and it would go to the server, the processor, which would, as I said, the big machine like twice this room. And whatever program you write, you would get the printout the next day. It might sound funny to all of you in these days of laptops and mobiles, that this is how it used to function. But the point is the technology has moved so fast. And it's an exponential rate of change. So what used to take place 20 years earlier took 10 years and further on 5 and so on and so forth. So we are at it's a beautiful time to be active in this area. A lot of things are happening. And the value of distances is diminishing. Earlier, you were at a distinct disadvantage if you were, let's say, in Delhi compared to San Francisco. And you were at an even greater disadvantage if you were, let's say, in a place like Bhopal or Lucknow or Meerut compared to Delhi. And you were at a still greater disadvantage to, the place where I studied, a small place, town called Modinagar in UP, compared to Lucknow or Bhopal or Meerut, etc. So these differences have now diminished. Now it becomes less and less important how, where you are. It is not that it is not important, but it has become less and less important where you are. Technology has bridged these distances. It is now the value of an idea, the strength of an idea that matters more. I presume most of you are from technical backgrounds. I understand that the technical education in the state, there are challenges there. But I would also feel that these days there are online methods to address that deficiency. I suppose the passion or the interest that drives most of you to this place is not really because of what you are taught in your classroom. But really, perhaps it would have at best created some sort of a building block over which you could climb or put atop your passion, your interest, and that is what brings all of you here. So it is not really what is taught in the classroom. What is taught in the classroom is more of an enabler that allows you to fly high. To be honest, I have done a lot of work in renewable energy, and I studied electrical engineering. But I must say that for example, a paper on what, a case study on what I have actually done is actually being taught in Harvard. It's not Singapore Management University. But I must be honest that there is very little of what was actually taught in BTech Electrical Engineering in IIT Delhi, which was enabled me to do that directly. But perhaps what happens is that it gives you the confidence or gives you the basic knowledge to solve new problems. If you, you might think, as I said, my first statement was that nothing that I said, I studied directly prepared me for what I did. But conversely, had I not studied that, perhaps I would not have been able to do that. So someone with, let's say, with due respect to people who study history and Sanskrit, but let's say someone who studied history and Sanskrit might not have been able to do what I do, even though what I was taught in electrical engineering did not directly enable me to do that. So what has happened, because what happens that when you study, it makes your mind tick in that direction. It makes your mind think in that direction. And then you look for solutions in that direction. Also, it enables you to have contacts, to know people who have the right solutions. So you interact with them, that gives you, it's a beautiful interaction that you have. I was interacting with the organizers of the Google Cloud community who have organized this program. I had said that we would be very happy to incorporate the principles of what you are doing into our curriculum. See, one of the challenges of deciding the curriculum these days is that the people who decide the curriculum are those who had studied, are typically your faculty. So, so it is, I mean, they studied, let's say, 20, 30 years back. So for them to decide what the curriculum today should be might not always be the best thing, because they might themselves not be in step with the latest changes that have happened and what is required to be done. So one input that I had was that we would be more than happy to have your inputs in modifying our syllabus of what we teach in engineering colleges in the state. Furthermore, if you want to have any formal interactions with the students in the engineering colleges, in the polytechnics, in the ITIs, we would be more than happy to collaborate. And if you have some new ideas, now the present government policy allows a lot of work being given to startups and things like that. There are incubators coming up. So if there are incubators at large number of places, if you want to use those facilities, that is an option that you could have. I mean, I don't need to elaborate on that, but if any one of you want, there are facilitators. I mean, see, most of you are obviously, I mean, all of you are in the field of IT. Most of the incubators that we have are tailored largely around IT. So the incubator facility would really address your requirement. Also, there are specific policies to encourage startups and to encourage work being given to startups. So these are things that you could think of, and if there any interest in that matter, we'd be more than happy to take it forward. I would just finally like to say that I'm very happy to see the huge participation of all of you here, and how it's a natural agglomeration of people who are actually interested in something, who are here. Otherwise, when you were studying, then I suppose you would have to have some letter from a dean or your someone to make you come here on a Sunday morning. But if you're doing it on a Sunday morning without the force of your dean or whatever, that shows the natural interest that all of you have in this subject, in this area. And really wishing the best to all of you and to the Google Cloud community. Thank you so much.
Inside, sir. I request Mr. Aditya Shah and Mr. Mayur Rathi to kindly felicitate our Honorable Chief Guest, Mr. Manu Srivastav, Additional Chief Secretary, the Department of Technical Education, Skill Development and Employment, and Department of Cottage and Rural Industries, in the Government of Madhya Pradesh, with a memento. Kindly accept this as a token of gratitude from our side, sir. Once again, we extend our sincere gratitude to you to have joined us and motivate the attendees present here. Thank you, sir. I'd request all the speakers to kindly come up on the stage for a group photo. Thank you, sir. Thank you, all the speakers.
We have with us Mr. Ashok Vishwakarma. Mr. Ashok Vishwakarma is from GDE Web Technologies, who has 15 plus years of experience in driving technology for products used by millions of people, has sound knowledge of web technologies, system design, performance, databases, cloud, and tools. As a consultant, he speaks at tech conferences, writes blogs, and contributes to open source. His talk on Road to DevOps Engineer would cover which aims to assist students and professionals in comprehending the DevOps landscape and identifying the prerequisites necessary to get started. So let's welcome him.
So how's the जोश? इससे पहले वाली टॉक में तो बोर हो गए आई थिंक, है ना? ये उसका प्रीक्वल है, okay? Let's do this over there. So whatever he talked about what you do when you become a DevOps, and I'm here to talk about how you can become a DevOps, okay? So first, let me introduce myself. I'm Ashok Vishwakarma. I run a company called Impulsive Web, and I happens to be a Google developer expert as well. I've been in industry for around 15 plus years as of now, and I've worked with companies like Adobe, Google, and PayU and Paytm. The thing which I wanted to discuss in this is what exactly the DevOps is. Should we really care about it? How much importance that actually plays in our day-to-day role? How you can get started to thinking about moving into DevOps, and what sort of things you have to do over there, and what sort of things which I happens to do, and specifically those specific learnings from my side. So what happens is that when I was working in companies, I was playing majority of time the actual development role. And then when I started my company, I have to do all of those specific stuff as well. So DevOps was the one thing which every product I have to build for my client, I have to support the DevOps. So this whole thing is a little bit about my journey, that how I taken up that responsibility, what sort of challenges I have faced, what I have learned, and how you can also enable yourself in that specific domain if you want to. So majority of us thinks that the journey of DevOps looks like this, okay? And for most of the cases, it's actually true as well. Like, you have to know a lot of stuff before you even think about going into that particular zone. My idea here is to summarize that path in a way so that it becomes something like this. A smaller step, achievable steps, achievable goals, which you can think of taking up and then improving on top of that. So first thing first, what is DevOps? How many of you have any idea what DevOps is? Okay. So I didn't write this, ChatGPT actually did. And what it's saying is the methodology that integrates and automates the work and software development and IT operations. So to summarize this, I would say, remember when we have IT and admin and support, those people are taking care of a lot of day-to-day jobs like installing antiviruses, okay, installing system updates. Those IT admins were the people who are taking care of your development operations. And now we have put that into a very good word called DevOps, but it's expanded its nature in completely different direction when cloud get introduced. So we will be talking about everything around the cloud only, and how exactly a DevOps engineers and what's supposed to be the role this should be playing. What a DevOps engineer is, it's also generated by ChatGPT again. So it's similar thing. The thing which we have mentioned in DevOps, a professional who is doing that, that's called a DevOps engineer. So everybody in your BTech or your college, you may have seen this somewhere, okay? This is called SDLC, Software Development Lifecycle. How many of you remember that? Cool. So the first step in that is planning, okay? Nowadays we have product managers, okay, product owners, and lots of business people who kind of do this planning stuff. Then we have building. Building is something which we do on day-to-day basis, okay? We kind of take those unnecessary requirements, code them into software and pieces, whatever garbage it came out, and then we hand over to our cool people, the QA guys, okay? Here is the responsibility, test it and make it work. They test it, they find bugs, those bugs get resolved, and then the deployment happen. Deployment is something which taken care by the DevOps people. Then the next step is monitoring. Monitoring is also sort of responsibility of DevOps people only, but those DevOps are little different than what these deployment DevOps are doing. And for actually once and all, this is what a full stack look like, okay? Having just knowledge of front end and back end doesn't look like a full stack engineer. This is what a full stack engineering is supposed to be. And this is what we'll be talking in this whole DevOps specific stuff. So first thing first, deployment. So majority of time what happens is that you build a software and you build that particular software by a specific process. Use certain tools and certain technologies. So when you want to release that code to production, there are n number of steps which needs to be taken. All these specific steps are combined into one specific stage in software development process called deployment. And that deployment is further divided into two separate pieces. Okay, one is this continuous integration, which means that whatever you need to do in order to package your application, build your application, and we also take the responsibility to generate just the builds. How it looks like is that you have some code, you compile it, you package it, then you have n number of testing to be performed, your unit testing, your integration testing, your end-to-end testing, performance testing, load testing, security testings, all those testing happen in that particular stage. And then finally it generates an analysis, okay? The static code analysis nowadays is kind of a term. Earlier it was a report which getting sent to people and then, okay, testing, passed and all. And then after that, it generates a package. That package comes to the continuous deployment. Continuous deployment is actually the process which takes that bundle code and deploy into multiple servers. So as of now, the process is not that only one individual machine where the code needs to be. You have a load balancer. Behind that load balancer, you have tons of servers which actually getting replicated with an updated code. So there is a different process to do that. So the continuous deployment looks like this. You have your build, you have certain bash scripts or Puppet or certain automation programs which take those specific things, deploy it on a testing environment first. After it deploys on testing environment, you again do some testing. These are UAT testing, I would say, like user acceptance things which our product manager and QA actually prepare. And then the release process starts. So the previous one, we call it the build pipeline, because every step we do over here is catered to the build, and then the output is a package. And here, what we do is we make this pipeline to make the release happen, like from one specific location to distribute that code in n number of nodes which we have in the system. Then the next responsibility of DevOps engineers is called monitoring. Monitoring is something which lets you monitor whatever you have deployed, how they are performing. Are they doing the work they're supposed to do? Are they having those specific features and functionality enabled? So the thing we monitor in this monitoring process is matrices. So matrices are your pure numeric values, okay? How much uses your resources are getting, like your hardware uses, your CPU uses, RAM uses, and tons of disk storage and other specific aspects. Then you talk about your response times, your throughputs, and all those specific aspects around that. So whatever numeric value you measure, that's called as matrices in DevOps language. Then we have logs. We also call it logging. All of the textual values, like the things which we generate, the things our services generate, the thing our pipeline generates, all those textual information actually called as logs. These could be your access logs generated by your web server, error logs generated by your third-party services, and your request and other specific logs like, okay, I just want to dump the whole request object into my log just to, actually for sake of, actually tracing is back. Then we have traces. So traces comes handy when we have a multi-system architecture, okay? We have multiple nodes, traces become very important. When we have multiple microservices, traces become very important. When we have lots of third-party integration, actually traces become very important, because actually what traces provides you that once you initiate a request and until that request sends a response back to the initiator, every specific system it's talked to, every specific origination and deletion what has happened, all those specific information is available in traces. So you can see how request initiated, where it actually went through, what kind of mess is made, and then come back to the user. So all those specific scenarios happens when you have microservices, third-party integrations, or an infrastructure behind a load balancer. The next thing what actually monitoring needs to do is, so we have gathered all this information. We have matrices, we have logs, we have trace. Now we also need to have some alert mechanism, okay? We need to inform ourselves and the audience or the people who are responsible for that particular deployment that what the hell those specific errors or code is supposed to do. And the channels we are using over here is email, SMS, Slack integration. Sometimes we also use other specific integrations, or it's always good to call people over there on the phone. So that is still not there, but I don't see it's not feasible as of now. People are integrating VoIP services to do that as well. Then we have gathered all those information. We have alerts and everything running. Now we need some mechanism to show that information to every specific stakeholder. Dashboards comes handy on those specific cases. There are Tableau, Power BI, Grafana. These are the examples of some of those specific solutions which you can use behind any specific data store, and you can actually populate any way possible graphs, charts, logs, and actually all those specific aspects around that. The other important aspect of monitoring is feedback loop. So remember, whenever you read an article or you go on Google or some other specific aspect or try to do something different, there is a one specific question they ask, was this helpful? And there is an actually thumbs up and thumbs down. This is called the feedback system. So every feature you use, every services you request, every specific time you spent on especially those systems, the owners wants to collect some sort of feedback that how they did, like and these feedbacks are helpful to improve the system based on your feedback, also formulate new product ideas and strategy around that. So this also become a very important inside the monitoring ecosystem. Okay, so this is the things which DevOps have to do. What are the actually career options which we have? So we have DevOps architect. I mean, they are the senior people in the DevOps ecosystem. They kind of become the backbone of the whole DevOps team. They are responsible to performing any specific scale operation or release operation or automation operation. Similarly, everything else falls alongside, like automation engineers are responsible for automation, security engineers are taking care of security aspect of the DevOps, integration specialists are thinking that how we can integrate multiple services into one and automate them. Similarly, the release manager is the last, especially the last people into the ecosystem who manages that once code is built, how it's going to distribute it among multiple nodes. So, any questions so far? Okay, let's move on to the next step. Why it's important? So I'm just thinking about a perspective here that why it's important for me when I was doing my business. So majority of these specific scenarios works for businesses and product owners, but there are a lot of insights for us developers as well over there. So speed is one thing which actually works well when you use the DevOps practices. it lets you create better product. It lets you own everybody on their specific aspect. Like there is not only one specific person responsible for everything else. So it's actually increases your effort of releasing your code and deploying your code. Then it's also have some sort of mechanism by which you can have multiple deliveries going on a very parallel basis. Like take an example of certain big companies. They do n number of development in a single day, and that's feasible because we have continuous delivery available. They don't have to go manually trigger and deploy and release those specific pieces. They're an automation system which is working over there. Then we have reliability. Like if we have automation and mechanism and all those specific DevOps practices around that, our system become much more reliable. It's also help you on a scale. I mean, when you go from n number of user to 100 number of users and so far, your system needs to scale as well. If you invested in DevOps practices and if you know how DevOps works and you automated some of the processes, your scale would be just one click away. It also helps you in collaboration. When you define individuals with their specific goals and individuals with a specific responsibility, collaboration become much more easier. Very similar thing which we did on microservices. Similarly, we can do on engineering side as well. DevOps is a separate practice. And it's also helping in security because one person is responsible to managing all the configs. Okay, infrastructure as a code or policy as a code are the examples which actually is the practices by which we enhance the security of the system. So how you should get started? So there are some prerequisites which you should have. The first thing is you should have a basic understanding that how operating system works, what are the some of those specific concepts and all, and how the technology underneath our system and thread management and all those things, IO, file system pretty much works in a way. You also have to know at least one or some basic programming languages like Perl, Python, Node.js, I mean JavaScript or Bash. Anything works well. Then you also have to have very good understanding of networking concepts because DevOps is completely networking. Like talking to system is the only thing which DevOps solves. So everything happens on web happens through those TCP layers. So you should have a very good understanding of your networking concepts. And also along with that network security as well, that how you can think about especially firewall, proxies, reverse proxies and all those specific things. And you at least have some familiarity with cloud services like Google Cloud Platform, AWS, Azure, anything could work. So what you need to learn apart from that? So first thing you need to learn is CI/CD. As I mentioned in that, CI is your continuous integration and CD is your continuous deployment. So before go and try out some automated managed service on the long, try to create one CI/CD using Git and Jenkins. Jenkins is very good handy tool. It's a very raw and you will learn a lot if you try it out. Maybe you fail, but the idea here is to understand how this whole CI/CD things works. And you should avoid using GitHub Action or other pre-built services as I mentioned because the idea here is to learn, not to get the job done. Then you need to learn about containers. I mean, virtualization was there when we talk about virtual boxes and all. I mean, Dockerization and containerization were very old specific topics. Now Docker and container architecture become a very hot topic, but there are certain changes happens, but at a system level and OS level, you need to understand how this container works, how separate environment works, how we can separate our config from having any collide with other specific services, those things where containers works. So what you need to do is try to containerize your specific app. Maybe you have created a blog for you or something else, okay? Just containerize that specific app, try to run in a Docker and see what kind of challenges you're facing over there. Make sure you deep dive into Docker file because that's where the whole, rules and responsibilities lies. Then you also need to learn about container architecture. I mean, creating these containers on runtime, managing those containers. There are tons of tools available, but I would say that you should start with Kubernetes, the raw Kubernetes, and Docker Swarm or especially maybe OpenShift. rather than, and if you stuck somewhere, go and explore Google Kubernetes engine. It have pre-built recipes which you can start with. Then you have configuration management. The configuration management is something where you have those individual configuration available on a common place, which you take and then scale your system from especially one node to n node. This configuration could be your environment variables. This configuration could be your security aspect, your certificates, and other specific aspects around that. There are certain things like Ansible, Puppet, and Chef you can use if you want to go in a raw and a learning perspective. But if you want to try out and understand that how it can be done, then Google have a very specific service for that. Infrastructure provisioning is another thing. How you can write some code which can create new servers on the fly. Those are the infrastructure provisioning stuff that you can also explore if you want to do on your own, or if you want to just go on Google platform and specifically use some services over there. Then monitoring. You need to expand a little bit on monitoring, like what sort of things the monitoring happens, how you can set up monitoring, how you can create an infrastructure around monitoring. And also, if you're stuck somewhere, Google have already a service around called Google Cloud Monitoring, which you can spin up and look into. So learning doesn't stop there, it's continues, okay? Like you need to learn about I/O, you need to learn about thread and process management. So DevOps is something where you need to have a very vast understanding that how systems actually works. And these are the things which we learn in our engineering classes, but because those are not being used that much and we kind of tend to forget. But when you go into DevOps, these things gonna come back and you need to have a better grasp on these. So try to learn as much as possible. But yeah, there are so many things to learn. So here are some key points which I observed when I was doing the transition and trying to do some of the specific aspect. So Linux is one thing which you should love if you want to go in DevOps direction, because the reason is very simple. Majority of production servers are Linux. So that's where you will be facing Linux on every specific aspect. You need to learn a little bit about version control if you're not, because everybody, I would say, that using some sort of version control, and Git is the most popular one. So you also have to think about learning some of those specific aspects as well. Then you also need to spend some time on trying out some of the cloud services. Like the idea here is to know what actually the service is and what kind of service it actually provides and what problem it solves. You also have a little bit familiarity of system design, how one system talks to another, how the connection happens between them, how latency and everything works in those, how the scale, how we can scale that system, how caching and everything else works. So system design is also play a very vital role when we talk about DevOps. Generally, these system design stuff, DevOps people does not have to do, but they need to have a fair amount of understanding to create an infrastructure around that. Then you also need to think about security. Like I told you earlier, that security is something which is very important for a DevOps. So you need to think about ways to sanitize your logs so that no PIL information or some sort of information which is sensitive can get into the logs. You need to also think about how you can protect your environmental configuration, like your environment variables, your CA certificates, your security tokens, and all those specific aspects around that. And you have to be patient. And that's a very important one. Because there is a lot of things to do in this, and you only need to do is step by step. So if you're not patient, if you're trying to do everything at once, things things gonna get very dirty. And frankly speaking, I'm still learning in those specific aspects. And I would say that everybody is doing the same thing. So nobody knows everything at once. You just have to go on a step by step. And here are some resources which I think can help you if you want to dig deeper and try to actually get your hands dirty. So this roadmap thing you should check out, and then you will figure out that how vast the roadmap for a DevOps engineers are. And these are the one, like some certifications are available which you can take after you learn some specific aspects around that. And you also, if you want to learn the whole cloud infrastructure and how cloud works, you can go on Google platform/learn, and there are tons of articles available over there. So that's all from my side. If you have any questions. Yeah. Can someone give him a mic?
Hello.
Yeah.
Yeah, first of all, thanks for your great session on how to get started with DevOps. So my question is about, I wanted to ask about the job prospects and job opportunities available for a DevOps engineer in India.
So, see, as I mentioned that now we are moving in an era where lot of these responsibilities are separating out, okay? Like earlier, we were tend to do back end and front end. I mean, I don't know how much of you remember the PHP era. There was no front end and back end, like everybody was doing the same thing. Now we see a clear distinction over there. Similarly, it happening in other specific dimension as well. But yeah, I mean, these things happening on a very process-oriented companies. I mean, companies who are doing specific tasks around very high scale. They are taking about those specific things. The idea here is to why I given this specific things in this specific conference is that every engineer should know a little bit about DevOps. And the reason being that is because you are there to build stuff, okay? If you're not able to release those stuff to the public or specifically to the user and you pass on that responsibility to somebody else, you will not able to see that how those, I mean, whatever you have built is actually not being used. So idea here is to think about actually reducing that gap and try to get your hands dirty on that. As per your concern about job prospect, so DevOps is something is going to get merged into the development itself. So whether you talk about doing it willingly or not willingly, it's going to happen. Similarly, what happens with testing, okay? Now we are writing unit test, integration test, and all those specific aspects around that. So this is what is going to happen on DevOps as well. So job prospects will remain same. It's just the responsibility gonna get wider a little bit. Yeah, yeah. Sorry? Okay, benefits of what?
What are the core benefits of DevOps?
So I think I have actually explained that why DevOps is important, and those are the benefits which companies and product needs to have. I mean, you need to think about certain aspect around those specific cases, like when you are building something, it needs to go on a specific user hands, okay? And there is a process to that. Who gonna manage that process, that running it efficiently? And it increases, I mean, I can give you one specific case study. So Atlassian, I have some people working over there and I also done some case studies with them. They release approximately 1,000 of experiments on Jira every specific day. Would you think that's possible if DevOps was not there? If automation was not there? So they are experimenting that much so that they can serve their user better, they can make the product better. And these are the benefit DevOps provides with the automation tools, infrastructure, clouds, and all those specific aspects around that.
Thank you, sir.
Okay, thank you everyone. I'm still available if you have any other question. I think we can connect.